Hey everyone, ready to dive into the world of engineering? Let's get started. Welcome to the fascinating world of electronics. Today, we're diving into a crucial component that often goes unnoticed, but plays a vital role in every circuit: resistors. So what exactly are resistors? Simply put, they are passive electrical components that limit the flow of electric current in a circuit. By doing so, they help protect sensitive components, control voltage levels, and ensure that devices function properly. Imagine a water pipe where resistors act like valves, regulating the flow of water to prevent overflow. In this video, we'll unravel the mysteries of resistors, exploring their types, functions, and why they are indispensable in both simple and complex electronic devices. Get ready to enhance your understanding of these tiny yet powerful components that keep our gadgets running smoothly. What is a resistor? A resistor is an essential electronic component designed to limit the flow of electric current in a circuit. The concept of resistance is key here. It measures how much a material opposes the flow of electricity. Higher resistance means less current can pass through, while lower resistance allows more current to flow. Resistors come in various types. Fixed resistors maintain a constant resistance value, while variable resistors, like potentiometers, allow users to adjust resistance as needed. This flexibility is crucial in applications like volume controls in audio devices. Resistors play a vital role in controlling both voltage and current, ensuring that electronic components receive the appropriate levels of power. Without resistors, circuits could easily become overloaded, leading to malfunction or damage. Understanding resistors is fundamental for anyone looking to grasp the basics of electronics. How resistors work. To understand how resistors operate, we must first explore Ohm's law, which states that the current flowing through a conductor between 2 points is directly proportional to the voltage across those points and inversely proportional to the resistance. This relationship is expressed as V equals IR, where V is voltage, I is current, and R is resistance. The materials used in resistors significantly influence their resistance values. For instance, copper has low resistance, while materials like carbon can offer higher resistance. When current flows through a resistor, it encounters opposition, leading to energy dissipation in the form of heat. This phenomenon is known as Joule heating, and it's why resistors can become warm during operation. Understanding these principles helps us appreciate the critical role resistors play in managing electrical energy within circuits, ensuring devices function safely and efficiently. Applications of resistors. Resistors are integral to a wide range of everyday electronics, playing crucial roles in devices we often take for granted. For example, radios and computers rely on resistors to manage current flow and ensure proper operation. One common application is in voltage dividers, where resistors are used to create specific voltage levels from a higher source, allowing circuits to function correctly. Additionally, resistors are essential in signal processing, helping to filter and amplify signals in audio and communication devices. They also serve a protective function, safeguarding sensitive components from excess current that could lead to damage. By limiting the flow of electricity, resistors help maintain the integrity of circuits, ensuring that everything from your smartphone to your home appliances operates smoothly. Understanding these applications highlights the importance of resistors in electronics and their impact on our daily lives. Choosing the right resistor. Selecting the appropriate resistor for your project is crucial for ensuring optimal performance and safety. Understanding resistor ratings and tolerances is the first step. These specifications indicate how much resistance a resistor provides and how much it can vary from its stated value. This is important because using a resistor with the wrong rating can lead to circuit failure. To identify resistors, you'll need to read resistor color codes, which use colored bands to indicate resistance values and tolerances. Each color corresponds to a number, making it easier to determine the resistor's band specifications at a glance. Additionally, calculating resistance values for specific applications involves using Ohm's law and considering the desired current and voltage in your circuit. By following these guidelines, you can confidently choose the right resistor to meet your project's needs, ensuring reliable and efficient operation. Common misconceptions. When it comes to resistors, several myths can lead to confusion. One common misconception is that all resistors are the same and interchangeable. In reality, resistors come in various types, values, and tolerances, each designed for specific applications. Using the wrong resistor can significantly impact circuit performance. Another misunderstanding is that resistors only limit current. While they do that, they also affect voltage levels and overall circuit behavior. The placement of resistors within a circuit is equally important. For instance, a resistor placed in series will behave differently than one placed in parallel, influencing how current flows and how voltage is distributed. Understanding these nuances is essential for anyone working with electronics. By debunking these myths, you can make more informed decisions when designing and troubleshooting circuits, leading to better performance and reliability in your projects. In summary, resistors are fundamental components in electronics, serving essential functions such as limiting current, controlling voltage, and protecting sensitive devices. We explored their various applications, from radios and computers to voltage dividers and signal processing. Understanding resistors is crucial for aspiring engineers, as it lays the groundwork for designing effective and reliable circuits. By grasping concepts like resistance values, tolerances, and proper placement, you can enhance your skills and knowledge in electronics. That's all for today. Stay tuned to Tech Blueprint for more clear and practical engineering content.